Hello everyone, my name is Ayush Murari, pursuing BTech in Electronics Communication Engineering third year. As a part of internship, which is provided by the EMERTXE, I have done a project home automation which is based on the Internet of Things. These are the contents of my presentation in which I have included the topics learned during the internship: C, Embedded C, Introduction to IoT, Working of IoT, Applications of IoT, Embedded Systems, Components of Embedded System, Problem Statement, Software and Hardware Requirements, Project Overview, Working Explanation of the Project, Project Demo, and the Conclusion. The topics learned during the internship is C, Embedded C programming, Introduction of IoT, Introduction of Embedded System, Project Requirements. We learned about the Arduino IDE, overview of the PicsimLab, different peripherals programming, and we learned Blynk app configurations, project integrations and testings. We have attended DISA workshop and we learned about the scope of IoT and the resume building. C and embedded C programming. C is a general purpose procedural computer programming language supporting a structured programming, lexical variable scopes, and recursion with a static type systems where C is used. System software development. Embedded software developments, OS kernel developments, firmware, middleware, and driver development, file system development, and many more. The main features of the C language include low-level memory access, a simple set of keywords, and a clean style. These features makes the C language suitable for system programming like an operating system or compiler development. Now, embedded C. Embedded C is the extension of the C language and it is used to develop microcontroller based application. The extension in the embedded C language from normal C is the IO hardware addressing, fixed point arithmetic operations, accessing address space, etc. Now, what we learned in C and embedded C: basic data types, int, char, floor, double, data type modifiers and qualifiers like short, long, long, signed, and unsigned. Conditional construct. In conditional construct, we learned about the if else statement, if else if, switch, for, while, and do while loops. In operators, we learned about the arithmetic, logical, relational, and assignment or bitwise operators. We learned about the arrays, pointers, functions. In functions, functions call, pass by value, pass by reference. Recursions, strings, memory segments, storage classes, and preprocessor directives. Now comes to the IoT. What is IoT? The network of physical objects that contains embedded technology to communicate and interact with their internal states or the external environment. Now comes to the working of IoT. There are mainly four parts of IoT. First part is the sensors and actuators. Sensors and actuators works in the opposite principle to each other. A sensor is a device that senses the physical changes in its environment and produces electrical or electronic signals. For example, a temperature sensor senses the temperature across its environment. Similarly, a humidity sensor senses the humidity. Or an actuator is a device that makes physical changes when it gets electrical or electronic signal. Now the second part of an IoT is gateways. Gateways are responsible to transmit data of an IoT system through the internet. They modulate and demodulate the data for transmission. Gateway helps to transmit the data from the processor of the IoT systems to the cloud server for storing the data. The examples of gateways device is modem, GSM system, Wi-Fi, etc. Now the third part of the IoT system is the cloud and server. Cloud server is the space for storing data. Cloud server stores all the data of an IoT systems and it serves with the users when they request it. This cloud server only helps to control the device over the internet. They serve the data with the users located anywhere in the world. Now comes to the fourth part of the IoT, that is the mobile app or the user device. It is the device actually where the data are used to observe the status and control the device of IoT system from anywhere. Now move to the further slide, that is the real world application of IoT. The one of the example that a smart home is the best example of IoT. If you could switch on the air conditioning before reaching home, IoT is used there. Switch off the lights even after you have left home, or unlock the doors to friends where temporary access even when you are not at home to make your life simpler and convenient. There are various applications of IoTs like in a smart home, a smart thermostat, connected lights, a smart freeze, a smart door locks. In wearables like a smart watch, activity tracker, a smart glasses, and many more. A smart cities in like a smart parking, a smart waste management, a smart marketing, remote access control, remote car controls, connected health in health systems, a smart retail, a smart supply chain, a smart farming. Now moves to the embedded system. What is embedded system? An embedded system is a microcontroller or microprocessor based system of hardware and software designed to perform a specific function within the larger mechanical or electronic systems. There are various examples of embedded systems like industrial robots, GPS receivers, digital camera, DVD players, MP3 players, microwave oven, set-top box, wireless routers, and many more. Now we will see the embedded system and its component. The main component of embedded system is microcontroller or microprocessor, which provides the computing and processing power to the system. Embedded system have a sets of basic I/O interface irrespective of its applications. For example, memory. Memory is the essential components which is used to store the program and application related data. There are various types of memory available which can be picked up based on the application's need. It can also have the application specific integrated circuit like FPGA and ASIC, application specific integrated chip, which are meant for the specific purpose. It can also have the diagnostic port. It is mainly used to measure the system performance. It also have human interface to interact with the human or the external environment. Embedded system requires some inputs from the external environment. Embedded system requires some inputs and outputs to interface with human and environment. Apart from this, most of the embedded system works in an analog environment where the system is reading some analog sensors input and controlling the actuators. So, to connect with the analog world, digital to the digital processor, we need analog to digital converter, and on the other hand, we need digital to analog converter. These all blocks are going to form the hardware part of the system. To make it as an embedded system, we need to connect software part which performs some specific task. After connecting the software part to all this hardware part, this completely make as an embedded system. Categories of embedded system. There are mainly five types of embedded system: a standalone embedded system, real-time embedded system, networked embedded system, mobile embedded system, hybrid embedded system. Now the problem statements for the project is the home automation should be simulated on the PicsimLab Simulator. Blynk IoT mobile app application is used to control the devices, and we should able to control the lights, temperature of the home, inflow and outflow of the water in the water tank. Now we will see the software used uh, for building this project. Arduino IDE, PicsimLab, Blynk IoT, Null modem emulator are some softwares which are used for building this project. Now the hardware requirements. The hardware requirements are the Arduino, LED, CLCD, temperature system, LDR, serial tank, Ethernet shield, and Blynk IoT app. Now about the Arduino Uno. Arduino Uno is a 8 mega 328 microcontroller, and its operating voltage is 5 volt and 3.3 volt, and the input voltage recommended is 7 to 12 volt, and the input voltage limits is 6 to 20 volt. There are 14 digital IO pins in Arduino, and 6 pins are provided for the PWM, pulse width modulations, and there are 6 analog input pins. The Arduino Uno have 32 kilobytes of flash memory, 2 kilobytes of SRAM, 1 kilobytes of EEPROM, and its clock speed is 16 megahertz. Now about the character liquid crystal display CLCD. It is a alphanumeric CLCD display, meaning that it can display alphabets and numbers both. Consists of two rows, and each row can print 16 characters. Can work on both 8-bit and 4-bit mode. Now about the LDR sensor. Photoresistor, also known as the light dependent resistor, LDR, are the light sensitive device most often used to indicate the presence or absence of lights, or to measure the light intensity. In the dark, their resistance is very high, sometimes up to 1 megahertz, but when the LDR sensor is exposed to the light, the resistance drops dramatically, even down to a few ohms, depending on the light intensity. Temperature sensor that is used in our project is LM35. LM35 is a temperature measuring device having an analog output voltage proportional to the temperature. It provides output voltage in centigrade Celsius. It does not require any external calibration circuitry. The sensitivity of LM35 is 10 millivolt per degree Celsius. As the temperature increases, output voltage also increases. This is the block diagram of my project, in which I have connected LDR sensor, temperature sensor, water tank, CLCD, LED, temperature system, and Blynk IoT app with the Arduino. Now we will see the working part of the project. The first working is the garden lights control. Inputs is the LDR sensor that read the LDR sensor value based on the reading from LDR, vary the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight. Temperature control systems. Inputs is the temperature sensors that reads the temperature from the temperature sensor LM35, display the temperature on gauge widget. Heater cooler control system. Button widget is the input on the IoT Blynk app. Detect the change in the logic level. If the button widget is at logic high, turn on the heater or cooler. If the button widget is at logic low, turn off the heater and cooler. Threshold temperature control. Read and compare the temperature with 35 degrees. If the temperature is more than 35 degree, turn off the heater and send the notifications to Blynk IoT app and display the same on the CLCD. Display the volume of the water in the water tank. Now the inputs is the cereal tank. Read the volume of the water in the tank by sending commands through the serial communications. Display the volume of the water on the gauge widget. Display the volume of the water on the CLCD also. Inlet and outlet valve control. Button widgets on the IoT app is the input and detect the change in the logic level. According to the logic level, it will turn on or off the widget. If the button widget is at logic high, turn on the inlet outlet valve by sending the commands through serial communication. If the button widget is at logic low, turn off the inlet outlet valve by sending commands through the serial communication. Control the volume of the water in the tank. Inputs are the cereal tank. Read the volume of the water in the tank by sending the commands through serial communication. If the volume of the water in the tank is less than 2000 liters, turn on the inlet valve and send the notification to the Blynk mobile app and display the same on the CLCD. These are some pictures I have added from the Blynk IoT mobile app. This is the whole output of my project. Now we will see the demonstration part. Now we will see the simulation part of the project. First, we load the hex file. So I am loading the hex file. Connect the serial remote tank. Now we will see the functionality of the LDR sensor. During the daytime, resistance of the LDR decreases and light will turn off. During the night, resistance of the LDR increases and light will turn on. As we can see here, as we increase the resistance of the LDR, the light will turn on, and if we decrease the resistance of the LDR, light will turn off. Now we will see the functionality of the heater and the cooler. Read the temperature and display on the gauge widget and same on the CLCD. If we turn on the heater widget, heater will turn on, and if we turn on the cooler widget, cooler will turn on. Now, if the temperature is above 35 degree, then the heater will turn off and the notification will send on Blynk IoT app. That is, temperature is above 35 degrees Celsius, it will turn off the heater automatically. Now we will see the functionality of serial remote tank. Read the volume of the water in the serial tank through the serial communication. Display the volume of the water on the gauge widget and same on the CLCD display. Now we can see the volume of the water is 2010. Now if we turn on the inlet valve, the water level start increasing. If we turn on the outlet valve, the water level start decreasing. If the volume of the water is less than 2000 liter, then inlet valve automatically turn on. See here, the volume is less than 2000 liter, water inlet enable. This is the whole functionality of the project. Now we will see the conclusion part. Using Blynk IoT application and Pixim Simulator, we simulated home automations where LED temperature systems, serial tank resemble light, heater, cooler, and water tank in real life. CLCD act like a dashboard used for displaying the events. Widgets from Blynk IoT app like button widgets are used to control heater, cooler, and inlet and outlet valves. Gauge widgets to display the temperature and volume of the water. A special thanks to EMERTXE to provide this Wonderful internship opportunity for me. Thank you.